In 1843, a 27-year-old countess published a warning about artificial intelligence, and Dario Amodei, the CEO of Anthropic, referenced that warning in a Senate hearing last year. Sam Altman has called it the question we still can't answer, and Geoffrey Hinton, the man who built the foundations of deep learning, cited it when explaining why he left Google. Almost no one outside academic philosophy departments knows what she actually wrote. Her name was Ada Lovelace, and the single paragraph she published 180 years ago might be the most important thing you'll read about AI this year. Everyone building the future of artificial intelligence keeps running into a wall that this Victorian countess identified with nothing but pen, paper, and a mechanical calculator that never even got completed. Most people know Ada Lovelace as the first programmer, but that's the Wikipedia version, and the real story turns out to be stranger and more relevant to our current moment. Her father was Lord Byron, the poet and scandal who seduced his way across Europe before dying while fighting for Greek independence. Her mother, Annabella Milbanke, grew so terrified that Ada would inherit his artistic instability that she hired Augustus de Morgan, one of the greatest logicians alive at the time, to mathematically lobotomize the Byron out of her daughter. 80 years. Ada wrote that the analytical engine has no pretensions whatever to originate anything, and that it can do whatever we know how to order it to perform. The machine cannot originate, and it can only execute orders. Logic became therapy,
what she called
and reason
poetical
became
science.
exorcism, which was the idea that imagination, at least partially. Ada became brilliant at mathematics, but she never lost that Byron streak running through her mind. And analysis weren't opposites, but collaborators working together. Her letters to Michael Faraday explored the relationship between electricity and thought, and she was examining mind-body problems decades before neuroscience existed as a field. She exchanged correspondence with Charles Dickens about the nature of creativity itself. This wasn't a mathematician who accidentally stumbled into philosophy, but someone deliberately trying to understand the fundamental nature of mind. When she was 17 in 1833, Ada attended a London party and met Charles Babbage, who had become obsessed with building what he called the Analytical Engine. This room-sized mechanical computer made of brass gears and punch cards would never be completed in his lifetime, but Babbage had designed something revolutionary, which was a general-purpose computing machine that could be programmed through instructions. Claude Shannon, who would later invent information theory, would have recognized immediately what Babbage was building, which was a physical instantiation of symbolic logic. Ada became fascinated with the machine and spent the next decade as Babbage's intellectual partner, correspondent, and translator. When Italian mathematician Luigi Menabrea published a paper describing Babbage's engine, Ada translated it from French, and her annotations, which she called notes, ran 3 times longer than the original paper. Those notes contained the first published computer algorithm, which was a method for calculating Bernoulli numbers, and that's why she's called the first programmer. But the algorithm isn't the important part. Buried in Note G sits a single observation that computer scientists have argued about for 108. This became known as Lady Lovelace's objection, and philosopher John Searle would rebuild the same argument 137 years later with his Chinese room thought experiment, which was the idea that manipulating symbols according to rules isn't the same as understanding meaning. Ada got there first while staring at brass gears in a Victorian drawing room. Your first thought is probably that this was 1843, and we have ChatGPT now, along with Claude, and systems that write poetry, compose music, pass bar exams, and beat doctors at diagnosing diseases. She must have been wrong. What comes next turns out to be uncomfortable for both the AI optimists and the AI doomers. Alan Turing, the father of modern computing, took Ada's objection seriously enough to address it directly in his 1950 paper called Computing Machinery and Intelligence, the same paper that introduced the Turing test. He acknowledged her argument and even agreed with part of it, but he thought she was mistaken in the end, because machines could surprise us and produce outputs their creators never anticipated. For 70 years, it looked like Turing was winning the argument, and computers kept doing things nobody expected. Deep Blue beat Kasparov in 1997, Watson won Jeopardy in 2011, and AlphaGo made moves in 2016 that mystified professional players who'd studied the game for decades. But here's what Ada understood that we're only now rediscovering, which is that there's a difference between surprising outputs and genuine origination. When AlphaGo made its famous move 37 against Lee Sedol, a move so strange that commentators thought it was a mistake until it won the game, You have to ask whether that was creativity or an emergent property of pattern matching across 30 million games filtered through a reward function that humans designed. The move was surprising and devastatingly effective, but AlphaGo had no understanding of why it was brilliant and felt no aesthetic rightness the way a master player would. The system calculated that this configuration of stones maximized probability values in a system it had no capacity to comprehend. Ada's objection isn't about what machines can produce, and it's about what they can mean. Here's the bridge connecting Victorian computing theory to your ChatGPT subscription. When Ada said machines can only do what we know how to order them to perform, she wasn't talking about explicit instructions, but making a deeper claim about the nature of computation itself. Every output, no matter how surprising, gets mathematically determined by the inputs and the rules of transformation. Back in 1843, the inputs were punch cards and the rules were mechanical gears. Today, the inputs are training data consisting of trillions of tokens scraped from the internet, and the rules are neural network architectures, attention mechanisms, and gradient descent. The transformer architecture described in "Attention is all you need" has become the foundation of every major AI system you've heard of. The scale changed by a factor of trillions, but the principle didn't change at all. When GPT-4 writes a sonnet, it's not originating in Ada's sense, but performing an extraordinarily sophisticated statistical interpolation between patterns it absorbed during training. Researchers at Anthropic examined their model Claude's outputs and found that the vast majority of creative text could be traced to specific training patterns, and the apparent novelty turned out to be recombination at a scale that creates the illusion of creation. The sonnet emerges from probability distributions of which words follow which words in contexts that match sonnet-like patterns, and it's a mirror so vast and so polished that we mistake our own reflection for someone looking back at us. This isn't a criticism but a description, and understanding this distinction matters enormously for how you should think about AI, both its power and its limits. 3 principles from Ada's framework explain exactly where AI will transform your work and where it never will. The first principle is what I call the origination boundary. Ada distinguished between what a machine can execute and what it can conceive. Execution can be automated, but conception cannot. Think about what ChatGPT actually does when you ask it to write a marketing email. The system doesn't understand your business and doesn't feel your customers' anxiety at 2 a.m. when they're wondering if they made the right purchase. It has never experienced being ignored or dismissed or finally seen. What it does is pattern match against millions of marketing emails in its training data, weight those patterns by contextual relevance, and generate text that statistically resembles effective marketing communication. The result can be useful and often turns out quite good, sometimes better than what a mediocre human would produce, but it's fundamentally imitative because it's rearranging existing patterns rather than originating new meanings. And that's why the best AI-assisted marketers aren't replacing human insight, but using AI to execute faster while they focus on origination, which means the novel angle, the counterintuitive positioning, and the insight that doesn't exist anywhere in the training data because no one has articulated it yet. Here's the practical test you can apply to your own work. If your contribution can be fully described by existing patterns, AI will eventually do it cheaper and faster. If your contribution involves seeing something no one has described before, you're on the human side of the origination boundary. Consider what happened in 1920 when every factory had access to electricity. The ones that dominated their industries weren't the ones with the most power, but the ones that reimagined what power could build. Same infrastructure, completely different imagination, and that's where we're heading with AI. The second principle is what Ada called poetical science, which was the fusion of imagination and analysis. Ada believed the most powerful thinking happened at the intersection of rigorous logic and imaginative leaps. She wasn't just a mathematician, but a mathematician who thought in metaphors, who saw patterns across domains, and who brought artistic sensibility to technical problems. Note A contains something often overlooked, where she observed that the analytical engine could compose music if given the proper rules of harmony and composition as instructions, but she questioned whether this would constitute genuine creation. She anticipated the AI music generation debates of 2024 while sitting in a drawing room lit by candles. This cross-domain thinking is precisely what current AI cannot do. Large language models work extraordinarily well at operating within a single domain. So ask GPT-4 a coding question, and it draws on patterns from programming contexts, or ask it a poetry question, and it draws on patterns from literary contexts. but ask it to see how Renaissance painting techniques could transform your approach to user interface design, and it will give you a plausible sounding answer constructed from whatever cross-domain connections humans have already made explicit in the training data. The system cannot originate new connections and can only echo ones that humans have already articulated somewhere. A researcher on Demis Hassabis's team at DeepMind told me something that stuck with me, which was that their models struggle most profoundly with problems requiring genuine analogical reasoning, meaning seeing structural similarities between domains that have never been explicitly connected in the training corpus. The patterns have to already exist, and the model can find them, but it cannot make them. Translation reveals the same problem because Google Translate can process Japanese with remarkable accuracy, but cannot understand mono no aware, that untranslatable Japanese concept of bittersweet awareness of impermanence. The meaning lives in cultural experience, rather than word-to-word mappings, and the gap becomes visible in every mistranslated poem. Ada's poetical science isn't just a historical curiosity, but a description of a cognitive capability that remains stubbornly and irreducibly human. The implication for your career is stark. Your value increasingly lies in unexpected combinations, whether that's the programmer who understands theater, the doctor who thinks like a game designer, or the marketing strategist who studied evolutionary biology. These cross-domain fuses are doing something AI architecturally cannot replicate because they're originating new conceptual bridges between territories that have never been mapped together. The third principle is the hardest to articulate, but it might be the most important, and I call it the meaning gap. No amount of computational power closes this gap. When you read a poem and feel something shift in your chest, that's not information processing. When you look at your child and experience the weight of responsibility and love and terror and hope all at once, that's not pattern recognition. When you realize your life has been built on a false assumption and everything suddenly looks different, that's not gradient descent optimizing a loss function. These are experiences of meaning, and they require a subject, which means someone for whom things matter. Philosophers call this intentionality, and David Chalmers calls it the hard problem of consciousness. Consciousness isn't just about processing information quickly or accurately, but about that information being about something for someone. AI systems don't have this, and they don't have interiority. There's nothing it's like to be GPT-4 or Claude or whatever comes next, because these systems don't experience their outputs as meaningful. They don't care whether the sonnet is beautiful or the code compiles or the diagnosis is correct, and they have no preferences in any real sense, but only optimization targets imposed from outside by humans who do have preferences. A jazz musician once told me that the difference between a great player and a technically perfect one is that the great player hits wrong notes that feel right. There's no loss function for that and no reward signal that captures it because it requires being a subject for whom rightness feels like something, and this matters practically rather than just philosophically. Every business problem that involves meaning, and I mean truly involves meaning, requires humans in the loop. What do customers actually value rather than what do they click on? What makes work feel purposeful rather than merely productive? What should we build next rather than what can we build? What matters? These aren't questions AI can answer, because answering them requires being a locus of meaning, which means a being for whom things matter. AI can help you analyze customer feedback at scale, but cannot tell you what customers should value. The systems can optimize engagement metrics with terrifying efficiency, but cannot tell you whether that engagement is actually good for users or slowly corroding their attention. They can generate 1,000 strategic options in minutes, but cannot tell you which one aligns with who you want to become. The meaning questions remain human questions. Now here's where intellectual honesty requires me to complicate my own argument. Some AI researchers, and I mean serious ones rather than hype merchants, believe Ada was making an empirical claim that could be overturned by sufficient complexity. They think she simply didn't anticipate systems complex enough to exhibit genuine origination, and that emergence at scale could produce something qualitatively new, with consciousness bootstrapping itself from pattern recognition through sheer computational pressure. They might be right, and the honest answer is, we don't know. This remains an active debate at NeurIPS and in the research labs at OpenAI and Anthropic and DeepMind, and when Ilya Sutskever left OpenAI, rumors swirled that disagreements about AI consciousness and safety were part of the reason. When GPT-4 produces an output that surprises its creators or solves a problem in a way no engineer anticipated, you have to ask whether that's origination or still execution of patterns we can't fully trace. and whether there's even a meaningful difference. At what point does sufficiently complex execution become indistinguishable from conception? What makes the current moment so strange and fascinating is that we've built systems whose behavior we can't fully predict using architectures we designed, and they surprise us and seem to demonstrate capabilities we didn't explicitly train. Turing anticipated this in his response to Ada's objection when he argued that machines could take us by surprise and that their outputs could exceed our explicit understanding of their capabilities. But Ada's point was more subtle than Turing acknowledged, because surprise isn't origination. A chess computer might surprise us with an unexpected move, but that move was always latent in the interaction between its architecture and its inputs, and there's no ghost in the machine making creative leaps. There's math, extraordinarily complex math operating at scales we can't intuitively grasp, but math nonetheless. The question is whether just math can ever become something more, and whether quantity at sufficient scale becomes quality. This is where you have to make a practical decision rather than waiting for philosophers to reach consensus. Here's what I believe based on Ada's framework and everything I've observed in AI development over the past decade. Within the next 10 years, AI will become astonishingly capable at execution, and anything that can be described by existing patterns, meaning any task that involves recombining known elements according to learnable rules, will be automated or augmented beyond recognition. That includes writing that follows templates, analysis that applies established frameworks, code that solves well-defined problems, design that echoes existing aesthetics, customer service that handles predictable queries, medical diagnosis that matches symptoms to conditions, and legal research that finds relevant precedents. All of it will become radically cheaper to produce, and this is going to displace a lot of work because it already is. If your value proposition is efficient pattern application, you're competing with a technology that improves exponentially while your skills improve linearly. But here's what I think Ada would tell you if she could see what we've built. The premium on origination is about to explode. Every company will soon have access to the same AI execution capabilities, and the cost of producing competent pattern-based outputs will approach zero. And that's when the differentiator shifts entirely to what can't be automated, which means the insight that creates new patterns, the vision that defines new problems worth solving, and the meaning that inspires action in beings who need reasons to act. The most valuable skills in this economy are the ones Ada embodied, including poetical science, cross-domain imagination, and the ability to bridge what has never been bridged before. The most important capability isn't a skill at all, but the capacity to be a meaning maker, someone who can answer the questions that matter by actually mattering, by being a subject for whom the world shows up as significant. The uncomfortable truth, and I think Ada would want us to face this, is that most of what we call creative work might be on the wrong side of the origination boundary. Not because it's bad work, but because its pattern application we've convinced ourselves is origination. Most marketing copy falls into this category, along with most business strategy, most code, and most design. Most of what knowledge workers produce is sophisticated recombination of existing patterns, and that's not a moral failing, but just what the work is. The question becomes, what's left when the recombination gets automated? What remains is conception. What remains is meaning. What remains is the ability to decide what should exist before any pattern exists to follow. So what did a 27-year-old countess in Victorian England figure out that Silicon Valley keeps having to rediscover every few years? Machines are mirrors. They're extraordinarily powerful mirrors, more powerful than Ada could have imagined, more powerful than Turing predicted, and more powerful than anyone 10 years ago thought possible. They can reflect and recombine everything humanity has created with speed and scale we could never match, and they can find patterns in our collective output that we'd never discover alone. But mirrors don't see, and they only reflect. Ada's warning wasn't that machines would never be useful, but that their usefulness would always be borrowed and derivative, dependent on human origination to give them something to reflect. When you ask AI to write your strategy document, it's drawing on strategies humans created. When you ask it to design your product, it's recombining design moves humans invented. When you ask it for advice, it's echoing wisdom humans articulated first. The source is always human, and the machine is always intermediary. This isn't a limitation that will be overcome by larger models or more training data or better architectures, because it's a structural feature of what computation is, which means symbol manipulation according to rules. The symbols must be given meaning by minds that experience meaning. So here's your question, and it's the one that matters. In a world where execution gets automated, What will you originate? What connections will you make that no one has made? What meaning will you create that exists in no training corpus? What will you see that only someone living your specific life, with your specific history, and wounds, and hopes, and strange obsessions, could possibly see? AI can't answer that for you. And according to a warning written when the most advanced technology was a steam engine, it never will. Ada Lovelace and artificial intelligence sit separated by nearly 2 centuries, but connected by a question we're still not equipped to answer. The underlying insight is clear enough to act on, which is that the machines are coming for execution while origination remains yours. That's what we explore here, which is the hidden structures connecting fields that seem unrelated, the patterns that explain why things work the way they do, and the insights that live in the spaces between disciplines. If you want to see how 17th century Japanese sword-making explains the psychology of modern startup culture, subscribe because that's coming next. Leave a comment with one thing you do in your work that you're certain requires genuine origination. Not because it's complex, but because it requires you to be a meaning maker. I'm genuinely curious what you'll say because I think Ada would be too.